One, slope fields.
I feel like if there were a lot of notes, like Stacy would have stopped us from
Probably.
And Euler's method.
It reproduced all right.
Yeah, I'm gonna pull some pages out of the prep books that I have for you for like some note stuff for this. One, so that you don't so we don't have to write it all down, and two, because I feel like they just do a better job of explaining it, so it makes more sense to give you that. But the stuff we're doing today, we don't really need, there's not a lot of notes for that. And the slope fields part, you're probably like, what in the world?
I know the slope one.
Yeah, I don't even know what a slope field is. I'm guessing it's field involving slope.
I know what a slope is and I know what a field is.
I don't know how they intermingle.
Ew.
And now that I'm thinking about it, I don't even know what Euler's method is.
Euler's? This is a slope field.
Oh, I see.
Okay.
Euler's.
You have to do them yourself.
That's a U.
You have to do it ourselves. We have to do it ourselves.
You have to draw one.
Nathan.
So, that's what you have to look forward to next week. But for now, we'll do easy stuff.
I'm gonna be so for real. I spelled it like oil, like oil. So for me, it's Euler's method.
This is the guy that the number E comes from.
Wow.
Oh, you got a whole like. That's cool.
I hate this dude.
Well, that's cool though. He got like a part of math.
Yo, I do not want to be known for something for math. Like,
People
I don't
would
want to
hate
put
me.
that impression on other people.
Alright, a differential equation, my favorite math class in college, is an equation involving a derivative, the order of a differential equation. I'm going to just abbreviate it DE for differential equation to not have to write it out every time we go to write it. Is the order of the highest derivative involved in the equation. Now, you probably haven't heard this term before unless you've heard me talk about the class that I took in college. However, we've basically done this before, okay? When we did the stuff that, where we were taking the antiderivative, and remember when we were doing that plus C part? Okay, now we're going to be finding C. Okay, so we'll be solving for C now. Sometimes it'll just say the general equation. The general equation is the plus C part. When it asks for us to solve it explicitly, then we have to solve for C and then plug it back in. So, nice and easy. So actually we're going to start with that because the notes that go with slope fields and stuff like that, you're going to get later either in that packet or I might give you a few things. But just as we go, I'll give you the notes for this because it's like 2 lines for each topic. So we'll just get it as we get to that stuff. So find the general solution to the exact differential equation. So they give us dy dx equals 5x to the 4th minus secant squared of x. So the general solution to the differential equation is just take the antiderivative of it. Oh wait, this is question 1, but that's fine. Not 2. I looked at the wrong problem.
Is that the end of the notes?
Yeah, well, sort of. For today, yes. So what is the antiderivative of this?
X to the 5th. Minus.
I think Christian knows it.
Tangent.
And then what do I need?
Plus C.
Plus C.
Now we gotta find C.
Not yet. These are just find the general.
Oh.
So yeah, these are, let me mark this. General solution. which means we leave the c. Let's see. 4. dy dx equals 1 over x minus 1 over x squared, and x is greater than 0. So what's the antiderivative of this? ln of x
Minus ln of x squared.
What's the derivative of ln of x squared? I'll give you a hint, it's not that.
Yeah, I figured when you said that.
How about if we rewrite this as x to the negative 2?
That could help. So it would be x to the negative 3. Wait, but something goes in front of
Add 1.
x to the negative 1. So,
And then what sign do I need here so that when I take the derivative I get this? What?
positive.
Positive, right?
Right.
I always do a double tap.
Because when we take
Yeah.
the derivative, we would have a negative out front and then x to the negative 2.
That is so.
And what else?
Plus c.
Plus c. I'm going to make you think on this next one.
I've already been thinking.
6. dy dx equals 1 over the square root of 1 minus x squared minus 1 over the square root of x.
This is what's familiar to me.
That's good.
Okay.
First part is.
That is
Yeah.
inverse sine.
Yep. Inverse sine of x. What about this part? How else can we think about this?
X to the negative 1. X.
X to the negative 1/2.
So we can. So let's start with putting the x to half.
Yeah, let's start by adding 1.
So x to the 1/2 adds 1.
So it's gonna have a
I don't know.
2 in front.
Okay, because if I put a 2 in the front and I take the derivative, I put this out front, that cancels out to a 1 and then makes that negative 1/2. What do I need to do about the sign?
It has to be negative. Still negative.
Still negative, yep.
Plus c.
Plus c. And you can, I don't care if you leave it like this, the book is going to write this as a square root. So they would write it like this. So either way is fine. Eight. Mixing it up. dy dt equals cosine of t times e to the sine of t. Any ideas? Or maybe what does this kind of look like?
Kind of looks like probably.
Right, but this is already the derivative, right? Huh?
I think Christian got it.
I said it looks like a mess.
Oh.
Oh.
He did get it.
I don't think you heard me.
I
Nathan.
thought you said something.
Looks like
Well, disregard this. What is this?
The
Let's do this.
Like I know the antiderivative.
Let
of that.
U equal
E squared.
sine of t. So du equals what? What's the derivative of this?
Negative cos. Wait, the derivative would be cosine.
Cosine of t.
Just use the antiderivative.
So perhaps this is e to the u du. Can you integrate that?
Yeah. I don't like this one. I need guidance.
All right, so sine of t is a function, right?
Yes.
Okay, so e raised to this. Okay, if I take the derivative, what is the derivative of e to the sine of t?
E to the sine.
Times.
The sine of t.
The cosine t.
Whoa.
Whoa, you just moved your. Wait, do that again.
Wait, what?
What's the derivative of e to the sine of t?
E to the sine of t times the cosine of t.
Oh, it's the same thing. That is.
So what is the antiderivative?
E to the sine of t.
Bingo.
Whoa, why is
What?
I'm just gonna, Stacy, I would not have gotten that without your help, by the way.
You will now, though.
Hopefully.
Okay.
All right. What am I missing?
Let's
Pussy.
see. Wait, but what does the U have to do with it?
I was just
I
letting
think
you
you
be
kinda-
that, trying to think. I thought you would see it
Oh,
if
okay.
it was written like that.
That didn't help.
That you would take the antiderivative and say, well, that's e to the u.
That threw me off. That-
But
That didn't help.
you can just disregard then.
Okay.
Like it's true, but if it confused you, just disregard it.
Yeah.
Bless you.
I did charge it up.
I heard.
10 dy du equals 4 times the sine of u cubed times the cosine of u. Any ideas?
No. So you get antiderivative.
It is a chain rule, but we're working backwards. But yes, but I mean, that is good to recognize because you are going to need that to figure out the antiderivative.
Oh, but so you got.
Oh, I know how to do it.
I'm sure she has some ideas, Nathan.
Sometimes I don't, but right now I do.
So it's like. So you.
Think about, okay, you said it's a chain rule, right?
Yeah.
So look at the pieces. Yes, yes.
Add on to the exponent.
Okay, yes. So that's going to give me, well, right now, sine of u raised to the 4th.
Okay.
Cosine you would have been raised to the 2. Wait, never mind. Just
Well, so look where you're at right now. Take the derivative of this, and what do you get? Peyton said the chain rule, so what does the chain rule tell us to do?
And then the
Take the derivative of the
Outside.
outside, which gives us what?
4 sine 3.
4 sine u cubed.
Yeah.
Then we take the derivative of the inside, and what's the derivative of the inside?
Wait,
So it's there. Plus
So
C.
you're done.
Plus
Plus C.
That's what I thought.
This
That's what I was thinking.
This is gearing us up for section 2 where we have to use substitution. It's a process, but that's the things you've got to look for. It's the thing that you would think of, and then you've got to realize, oh, it was a chain rule. Because, I mean, technically, this was a chain rule also.
Right. Right.
So it's like, look and see, okay, what can I maybe, like, take the antiderivative of, and then when I take the derivative, does it give me this? Because obviously you don't know a product rule for antiderivatives right now. So there's no other thing you can do about it but to do this, right? Okay. Solve the initial value problem explicitly. So solve explicitly. I'm going to show you one today, and then we'll pick this up on Monday. So 12, dy dx equals 2e to the x minus the cosine of x. Y is equal to 3 when x is equal to 0. So the first thing we're going to do, we disregard all this stuff over here about what y and x are equal to. I'm going to follow the process that I did from 1 through 10. So what's the antiderivative of this? What's the derivative of e to the x?
So it's 2 to the
2e to the x. Just copy it down.
Right.
Because the derivative of that would still be 2e to the x.
Right.
Now, what's the antiderivative of negative cosine of x?
Minus.
Minus sine of x
Plus C.
plus c. Okay, so that the first step is the exact same as the general part. Now, I'm going to plug in for x and y. So I'm going to have 3 equals 2e to the 0 minus the sine of 0 plus c. So what is 2e to the 0 equal to?
2.
What's the sine of 0?
1. 0.
0. So minus 0 plus c. So subtract the 2 over. So 1 is equal to c. So then now, to wrap it up, we plug this back in for c here. So we get y is equal to 2e to the x minus the sine of x plus 1. So now this allows us to actually know what c was. Previously, c was just a constant. We didn't know what it was. It might have been 0. We weren't sure. If it's just 0, then you would just rewrite it without anything there, if that ever happens. So we'll do obviously more with this on Monday, but the bell's about to ring, but I wanted you to see one.
Yeah, that was cool.
So you might not think slope fields are as fun, but I don't think slope fields are as fun. They're not that hard. They're just not enjoyable. They're very tedious.
Boom.